ideas that are out there to go beyond Earth, beyond even our solar system. And the first thing that we need to understand is the space is big. Obviously, we know how big planets are, and yet humans went only as far as the moon. And we think that is our local neighborhood, that's close enough, but it's still quite the big, hill going from the Earth to the moon. And if you see, we're passing all the planets, because if you take every single planet in the solar system, you can fit them quite comfortably between the Earth and the moon. So humans just went that distance. Yes, we're sending probe out there, but humans are not going out there yet. We've been sending stuff. This is pretty much what the Milky Way looks like. And here there is that dot. That dot is 200 light years across and is the extent of human radio broadcast. Still very, very tiny. I've been obsessed with astronomy since I was very little, and I don't just want to see the stars in my telescope. I want to see the stars with my own naked eye going out there. So I'm not alone with this passion, and a lot of people have been thinking big ideas on how to get, to the stars. So NASA sponsored this the Breakthrough Propulsion project, and the idea is to take everything we know about physics and forget about it. So I'm not going to go too much into details, but these are four the most important projects. This is the diametrical drive, so it creates a gravitational curl and generates an unbalanced force. Gravity is symmetrical, so everywhere you're on Earth, you're always pointing to the center. But what if there was an engine that could create an asymmetry in gravity? Then you would naturally have an unbalanced force, so that would pull you forward. This one was actually taught before we proved that there was an Higgs boson. So it has nothing to do with having, an Higgs boson cannon that you can shoot and suddenly you give mass to something or you take mass away. This simply think, okay, what if I can somehow modify the matter content of something without changing the gravity? Again, create propulsion. This one is saying, you know what I really hate in physics? That we have so many constants that don't change. How about we change it ourselves? And again, you would create a gravitational pressure just by simply changing the gravitational constant. And finally, this is my favorite on craziness, because it's a special sail that creates a pressure imbalance in dark energy. Dark energy is worth 70% of the matter energy content of the universe. We have no idea what it is. We just know that it pushed the universe apart, it expanded the universe. And yet there are people working on a way to harness dark energy to create a sail and navigate the universe with dark energy. So it's really interesting, but I'm happy to make fun of all this idea, but it's interesting that people are so passionate about going and exploring the stars that are trying to push the boundaries of what we know in physics. And we have some a little bit more realistic ideas as well. This is the EM drive. It's a reactionless engine. It means that it violates the conservation of momentum and sort of violates the conservation of energy, which you should say, that's not really good because you don't want to bet against thermodynamics. Thermodynamics always win. But there's something weird going on. They construct this engine, and when you put microwave in, somehow they bounce around, and there is a difference in thrust on the two ends. Your hand has less thrust, so you are creating a thrust that is only the micronewton, but as Russell mentioned before, it's perfectly fine in space. there is nothing physical that we can think of that should make this imbalance. But they measured it, and NASA is willing enough to spend money in actually trying to test and understand this. And there's only one, the problem with this is there's only one peer-reviewed paper that look at the possible causes. Everything else is, at the moment, a little bit of a cult. And they're like, oh yes, this is right. If you don't believe that this is correct, oh, you're wrong. You're one of those scientists that cannot be open-minded. It's interesting. I really want this to work, but at the moment, the science is not solid enough. But we know that our science is limited. We know that we don't have all the answers. So if they can prove that there's something that makes it work and it's not some weird thermal or electromagnetic effect from the Earth, great. Something that is actually hopefully gonna work is the breakthrough Starshot, which it was in news a few months ago. Stephen Hawking and a Russian billionaire that I can't remember the name right now, they want to send a tiny little probe to Alpha Centauri. The idea is you have a probe that is about between 30 to 100 grams with laser communication, with cameras and solar powered, and you have a big solar sail. You shoot laser to this sail and you accelerate to 20% of the speed of light. You will get to Alpha Centauri in about 20 years, so in about 25 years after it's sent, we would get images of another star close up with hopefully also the exoplanets. It's very interesting because the technology for this is already in development. The tiny little probe, there is this tiny space satellite called KickSat-2 that's going to be launched this summer. And the technology is there. We don't have everything sort of ironed out, but this could be the way that humanity explore the galaxy. Now, wormholes, my favorite, because they are allowed by relativity. Relativity gives this a solution. They're allowed by quantum mechanics because for wormholes to be stable, you need something like negative energy. Relativity tells you that, oh, there's no such thing as relative energy, but quantum mechanics doesn't care about relativity. And they say, yes, negative energy, you can make wormholes. And absolutely, wet dream of every nerdy kid. You're all here and you all want to travel through space and time. Wormholes allows you to do that. Fortunately, they're beyond current technology. And maybe also beyond physics, but we don't know yet because our two main physical theories allow them. So maybe when we'll find the theory that covers both of them, we'll find if they're actually possible. Another thing that is allowed by relativity and quantum mechanics is the Alcubierre Drive, which is a faster than light travel method. Requires the compression of space-time and exotic matter, and that is complicated stuff, but the way I usually explain this is the string in the hoodie problem. To get your string, when you pull it out of your hoodie, you need to sort of push the fabric of your hoodie and put the string through and then extend it, and that's exactly how it works. You're compressing all the space-time in front of you and you're extending it behind. And that allows you to travel faster than light without violating any laws of physics. So quite a good option. There is a minor problem that space is actually not empty. So when you're compressing stuff, you're just collecting all the hydrogen and dark matter and particles in front of you. So for example, let's see that we are going to Alpha Centauri. The moment we start accelerating, we'll start creating enough nuclear fusion in front of us to produce the energy of a supernova. If you were going to, I don't know, Andromeda, you would probably destroy many thousands of stars just by traveling. So not perfect, but it's giving us a good idea on what would happen if we travel a lot in space. Now, this one instead is something that is not only theoretically feasible, but we could actually build it somewhat. So, antimatter, we constantly produce antimatter. CERN produce a lot, but any major labs in the world produce antiprotons, anti-electrons. We don't know how to store it because once you create anti-hydrogen, it becomes neutral, and you don't have a field to contain it, so it touches something and annihilates. But if we could find a method to easily create antimatter, you could simply travel to the universe with no problem. And is like Russell electrical engines that we've seen. This will give you a constant acceleration. It's going to be quite small. It would take about 3 months to reach the orbit of Pluto. It would take about 10 years to reach Alpha Centauri, but then to reach the edge of the visible universe would take only 46 years, thanks to relativity, because your the acceleration is so regular, and I'm assuming 1g acceleration, that relativity will come and help you, and you would be able to travel about 40 billion light years than the visible universe as it spans since the Big Bang in your lifetime. We don't have technology, but you can think that maybe is how, if you really hate this planet, it's a good way to go. Now, finally, is a question that we don't know we don't have the answer, but is we need to always keep in mind: is faster than light travel possible? So, if it is possible, it means that is there new physics out there? We know that relativity and quantum mechanics are limited, but will the new physics allow for faster than light travel? Is it just old physics with a twist? Have we seen already in Alcubierre Drive or the Wormholes? Are those the way that we're going to use to travel faster than light, but we need something else that we don't know yet? Possibly. But if this we're saying yes to this, then we go back to the Fermi paradox. Where is everybody? Are we is there no way that if there are ways to travel faster in the speed of light that we haven't met anyone, that there's no civilization out there that can do it? So maybe we are the first, and maybe that's a good thing that we never met any aliens or seen any signal, because maybe we are the first in the Milky Way that are harnessing physics to travel. If it's not possible, then we need to think about what can we do to travel across the Milky Way, because I don't believe that humanity will just say, yeah, it's not possible, well, we're just going to give up on space, we'll just take over the solar system, but that's it. I think we're just too curious and a little bit too arrogant to just stay in the solar system. So are the robots the future? Can we send, I don't know, self-replicating robots to other systems to just create new copies and spread, I don't know, the message of humanity across the Milky Way? I think this is definitely a possibility. Even if we can work out a faster light, I think robotic exploration of the Milky Way is going to be the first step for humanity to go forward. And with that, done. That's my Twitter handle, and you can read my stuff on Faculty of Science and on my blog. Thank you.